Well, it's time to do another lesson by video, and today's topic is translations. No, we're not talking about translating language, we're talking about geometry. So here's the definition of a translation in maths. Shifting a figure in the plane without turning it is called a translation. So a figure could be a shape, it could be just a point, could be a closed shape or polygon or even just a line. But whatever the figure is, we are shifting it in a plane. Of course, we're not talking about an aeroplane, we're talking about a flat two-dimensional surface. So as we shift a figure in the plane without turning it, it is called a translation. If we were turning it, it would be rotating as well, and we'll talk about rotations another time. Now what we need to do is come up with some notation we can use in maths to describe translations. In simple terms, we're going to talk about how far left or right or up or down the figure is moved. If you have a look at the diagram which I've painted around, the blue triangle is being shifted to the position of the red triangle. You'll notice that it has exactly the same size and shape. The lines are the same length, or I should say the intervals that make up the sides of the triangles are the same length, and also the angles are identical. So nothing about the shape has changed except its position. You may have noticed that we've given it a new name. The new triangle is no longer called ABC, it's referred to as A-B-C'. So let's have a look at the actual translation. I've drawn a red arrow which shows that the point A has moved 2 units to the right and then 1 unit up. Now if that's true for point A, then it's true for all other points in the figure as well. So we could describe this translation as 2 units to the right and 1 unit up. Notice that each vertex of the triangle has a little dash against it in the image of the original shape. And remember, we simply refer to each point by now saying A dash, B dash, or C dash. It's also important to note that the lengths of the sides do not change, and neither do the angles. The image is exactly the same size and shape as the original figure. Alright, so we're going to look at how the blue triangle has been translated to the position of the red triangle. A very simple method is to simply choose one of the points and get out your trusty pencil and draw. So A dash is 3 units to the left and 1 unit down, and because we can see that the shape has not been rotated or changed in scale, we can simply say that triangle ABC has been translated 3 units to the left and 1 unit down. Now we can also abbreviate what we write by simply saying 3 left, 1 down. Okay, so now we need to actually do a translation. We're going to translate the triangle XYZ 2 units down and 3 units left. Once again, all we need is a simple method. So once again, get out your trusty pencil and show X being moved down 2 units, and to the left 3 units, and that is where we draw and label point X dash. Do the same for Y to find the position of Y dash, and for Z dash, and now we have the 3 new points which happen to be the vertices of the triangle. And so all you need to do now is get your ruler out and rule in the sides of the triangle, and you have found the position of the image of triangle X, Y, Z. Notice that every point of the triangle has moved. This is a special property of all translations apart from the identity translation. Now what on earth is an identity translation? Well, this is a special case where the shape doesn't actually move. It's been translated 0 units to the right and 0 units up. So the only thing that's been changed is that it's got a new name. So you can think of the identity translation as a special case where you rename the figure using the dash terminology. Alright, so let's summarize the normal case for a non-identity translation, which is another way of saying that the shape moves. Every interval has equal length, every angle has the same size as before, and every point moves. There are no fixed points, and that last point is important to remember. Okay, it's your turn now. You'll need some centimetre grid paper, a sharp pencil and a ruler, and you should be able to knock this set off within the lesson.